Guys, I've got some exciting news. This is the last maths video that I have to film, and then I have to edit for about 4 hours in a day when I do not have time for that at all. So the editing on these videos is not going to be good. By the time we get to the end of them, I may not even end up having questions on the screen. It'll probably just be cutting out the bits where I randomly started talking about something else. So I apologize for that, but it's realistically the only way that I could get it released. Anyway, so today I'm talking about congruency. I'm going to zoom through this so that I have time to edit. Basically, congruency, Luke did a video on similarity. Congruency is when it's mostly in the form of triangles, but this is where two triangles are exactly the same. So similarity is where they can be like in ratio, but congruency is when they are exactly the same. So once again, you do the same sort of proof style. You go in triangle ABC and triangle DEF, reason I, and reason III. Obviously, I do know that that is Roman numerals, and I don't just think they're I's. And then we've got, again, at the end, therefore, triangle ABC is congruent, which is line, so it's like an equal sign just with an extra line at the bottom, congruent to DEF, and then you have to put the test that you did at the end there. So that brings us into tests. There are 4 tests. We've got, first one is SAS, which is side, angle, side, but we don't have SSA or ASS because the angle has to be between those two sides for that test to work. The next test, so that's when we have two sides that are exactly the same and an angle between them that is exactly the same as well. The next one is SSS, that's when 3 sides are the same, all of them, they're the exact same length, which means that all the angles are the same. We then have angle, side, which is when 2 angles and 1 side are the exact same when they're to their matching ones. And then the final one is RHS, which is for right angled triangles only, which is where it's basically side angle side again, but it's your right angle, one of the sides, and the hypotenuse has to be equal. Okay, so we're going to do one quick example of this. I'm straight up going to be going really quickly through this. As quickly as, I will be going through this as quickly as possible, just so that it's not too long for you all, because congruence is quite an easy thing to look at. So for this one, I'm going to have this question up on the screen here, hopefully, if I can do it. So what this is going to be is that, so we're going to have to prove that triangle ABC is congruent to triangle EDC or ECD, or however you want to mix up the things. So how we're going to do this is we're going to go in triangle ABC and triangle EDC. So reason 1 I'm going to use is that AC is equal to EC, which is given, as you can see the 2 little lines there on each of them mean that they are the same. And so for everything that you do, you have to put in an actual reasoning as to why. And so what you can do for this one, because it tells you, is you can just put brackets given. Then I'm going to say BC is equal to DC. Again, I'm going to go brackets given because it's got those little lines there. And then we've got our final one, which is going to be angle ACB. So that's the one that goes into the C in the middle, is equal to angle ECD. And then you have to put an actual reason there. And I'm going to say because vertically opposite angles are equal. So we can then say, therefore, triangle ABC is congruent to triangle ECD, EDC. And then we go in brackets SAS, which is the proof. That was side, angle, side, because we have the 2 sides and then the angle between them. And then you can do a nice little thing at the end, which is hashtag QED or QED. That's just a thing. It's in Latin, I think. In Latin it means it is demonstrated. So basically that's all you need to do for congruence and similarity. There will be plenty of practice questions that you can look at that will hopefully use the other tests. But basically, I'll run over the test one more time. SAS, or side, angle, side. 2 sides, 2 matching sides on 2 triangles have to be completely equal to each other, with an angle between them also being equal to in the other triangle. SSS, all sides are equal to the matching ones on the other triangle. AAS, which is when 2 angles and 1 side are equal to the matching sides and angles on the other triangle. And then RHS, which is only for right angled triangles, and that's when obviously the right angle is equal because it's always going to be 90 degrees, and then the hypotenuse and 1 side is equal to the matching ones on the other triangle. So that's all we've got for similarity. No, for congruence. Luke did similarity. I hope you enjoyed. If you did, leave a like, subscribe, and watch our other maths videos because we've put in a lot of time to get them hopefully done. I say that, but there is a chance that they just won't get done. But anyway, If you enjoyed, please leave a like, subscribe, and goodbye.